Yeah, welcome to our community call. I'm Stephan, one of the founders of Restate, and well, this community call is basically a bit of an interactive demo of some of the examples and integrations we've built recently for agentic use cases. It's, I guess it's a bit of a cliche. Everyone does these days, but it actually turns out Restate is genuinely actually a very nice tool for some of these use cases. And I hope I can actually show you a little bit of a few nice bits there. It's also going to be a bit of a just a demo of some of the more recent features in Restate, specifically around like UI and observability and so on. So I hope that's going to be nice too. If you're interested, some of the background of what we're doing in this call is also in the recent blog post that we wrote. If you go to our blog on restate.dev/blog, durable AI loops. Some bits are also here. We're going to go into a bit more detail, more visualization, a bit more explanation here. And I think we need to do a few instances of this one, because initially, when we were setting this up, we were thinking we can actually show a bit how you can use Restate across a lot of different AI use cases and SDKs and different languages. But it turns out, I think we're not going to get through all of those within an hour. So let's actually start with one. Today we're going to do TypeScript and the Vercel AI SDK, and I think we'll just have to do another one in a week or two, and use, for example, the OpenAI SDK or the Google AI SDK. And that allows us to show also a few different patterns, because all of these SDKs kind of have different philosophies and takes, and it allows us to show a little bit how the whole philosophy of how Restate works with durable execution and state and durable communication. How this is a really nice orthogonal piece across different SDKs. So it's not a specific sort of agent runtime for any specific solution, but really the mission is sort of more general purpose resilient applications. And it looks like we have a few familiar faces, but also a few names I don't recognize, like folks that are here maybe for the first time. So let me take maybe 1 or 2 minutes just to give you a very brief introduction into Restate and generally how to think about building reliable applications with Restate before we go into some of the details. Okay. We can actually do this introduction with a small agent example as well. And yeah, I'm just going to go into code right away and share my screen. And by the way, I'm going to do a pause every once in a while and collect questions. Feel free to collect them in the chat in the meantime. And raise your hands if you have questions, and then every couple of minutes, we're going to do a pause and then go through all the raised hands and the questions, okay? All right, let's do that. Good, so here we go, fingers crossed. This is very much like alive and everything, so let's see if the demo gods are actually good with us today. Okay, so the simplest way to think of a Restate application, independent of whether you're building an agent or not, is that you're basically turning something that is like an RPC style application with request handlers into a durable application. So what I've written here is actually something that's completely without Restate at the moment. It's just a simple mini AI application that runs as an Express.js application. It runs on port 8080. It has a single root, agent run, takes a request, just forwards that to our function here, which itself is actually very simple. It just takes this prompt, sets up a model, and then uses this function here. This is all basically just Vercel's AI SDK. And for those who've never used this before, it's a fairly lightweight SDK that basically is a tool to help with interacting with, across different providers. Like we're using OpenAI here, but you can also use, Anthropic, Google, and you can specify these interactions. Here's a system prompt. Here's your user prompt. You can define a few tools that you make available, and then this is basically sort of a single interaction, which in itself can have a couple of steps. For example, if it involves tool calls. So if you do multiple steps, then each individual step will be an interaction with the model, which might tell you, okay, you're actually done. I can directly give you the answer, or call a few tools and then tell me what the tools say, and then we're going to do another round up to a maximum of 5. So far, there's nothing Restate specific about this. It's really just this simple function, the simple handler, and we can just simply start this. Let me see that I don't have anything else running on that port. No, it should be good. That should just bring this up. This doesn't actually look right. No, it's just the log output that's wrong. It's just the log output that's wrong, but it's actually listening on 8080. Okay. Anyways. Okay, and let us, send this a simple invocation. Just going to call localhost 8080 agent run, and the prompt is, what's the weather in Berlin? That's the prompt we selected because the one tool we actually made available to the agent is a tool that allows you to, allows it to access the weather. Okay, it tells me the weather in Berlin is currently sunny with a temperature of 23 degrees, and this is all of it so far so good. Let's look at what we would need to do to turn this into a Restate application, and it's not a lot. The philosophy of Restate is really we're trying to keep the shape of the application as close as possible to this type of sort of request RPC style microservices. So what we're going to do actually mainly is we're going to get rid of the Express.js entry point, and we're going to define a Restate entry point instead. It looks not all that different. We're defining a service here, we're giving it a name, and then the handler run. This implicitly gives us a root agent/run. It's a bit more sort of by convention in Restate. And then we're starting an endpoint where we can build multiple of these services, which are basically groups of handlers, and we're listening. We're listening on a different port here. And you can see this gives us actually access to the Restate context in addition to the request. So let's actually forward this here. And now basically we're serving the same thing through our Restate entry point, but that gives us a few interesting capabilities now. So we can actually now start doing using durable execution facilities. But maybe even before we do that, let's just start this and and bring this up. So we're studying this simple agent again. In our case now, we actually need to start the Restate server. The Restate server is just a single binary that we can fire up here, and then we're going to register that service as Restate, because the main philosophy of Restate is that you're not talking to the service directly, but you're putting a Restate as a sort of proxy or broker in front of it, and that way it sits in the middle of your request and can add the durable execution. So we've added this simple agent here. Restate itself runs under 8080 now, the agent under 9080, and we should be able to actually do the exact same request again. And we're getting this response. Can actually see that this went through Restate. We're just looking at the invocations, and cool. This was what we just did. We just get the the parameters. What's the weather in Berlin, and then the response. We didn't actually do anything else. We basically just got a durable invocation here. But one of the nice properties we kind of get immediately out of this is, let's say we're making this call and we're killing this thing on the way. Well, actually, it wasn't fast enough to complete it, but we to kill it. But we can actually decouple sort of the lifetime of that invocation from the actual connection and request. And if it dies in the middle and we bring it back, it's basically all a resilient connection. The interesting bit starts actually now. Let's actually start to use some of our durable execution magic. So the first thing that we might be interested in doing is actually saying, model calls. If we have a long-running agent, model calls are expensive and non-deterministic, and if it crashes after a couple of minutes, we don't want to repeat those because maybe they're actually going to give us a different response. We're going to go a different route, and also it's going to take the agent a long time to get back. So what we actually do here now is we're turning. Instead of using the model as it is, we're using basically middleware to make the calls durable. This in itself is, if we actually go into the definition, is an extremely simple thing. It's basically just a wrapper that says turn this into a durable step. What these wrappers look like, we can actually see here explicitly if we look at the tools, because we're going to do the same thing here. We're actually going to turn the tool into a durable step. Let me zoom in a little bit to make it easier for you folks to see. And the only thing we actually need to do here is, perhaps it's going to say reset.run. Let's actually give it a name, fetch weather. And then, this is the function. This is now our durable step. That's actually it. And if you wish, behind the durable model calls is exactly that. It's just a wrapper around this. That's really everything. Let's make sure we're running this, and if we're doing if we're calling this now again, what's the weather in let's actually take a different city, maybe that's the weather in New York. Like, we can actually go to restate here, and it's going to tell us now, because it actually really tracks each individual step. It's going to give us a very nice breakdown. Okay, the first thing we did is we're calling OpenAI, and this was what came out of it. We're supposed to call a tool called getWeather. Then we're actually calling the weather tool, which gave us temperature 23 and cloudy. Right, great. And this is the final response then that we got from the second inference call that we returned. So this is really, if you wish, for just getting some durability and visibility into some simple agents. This is basically all you need to do. It doesn't mean we're going to stop the community call here, because there's a lot more, but this is really, just want to pause here maybe for a second. This is basically all the set of changes you need to do. It. Let me try and show you one more thing, and let's, if you want, go into the first round of questions then. Here's another agent that answers slightly more interesting problems. As an example, again taken from the Vercel AI SDK. It's supposed to answer sort of mathematical questions, and it has a calculator as a tool. It's set up in the exact same way, right? Like, we're using it's just a regular interaction with that AI SDK. Using durable calls around our model to basically secure that. We're wrapping our inference, our tool calls to actually make them recoverable, and then we're serving them through the restate entry point. We're putting a bit of like schema information around it, but otherwise it's really exactly the same thing. Let's run this. This one gives us a little bit of a more interesting interaction history. So this one runs on 9081. It's a different service. I need to actually register this at Restate first. There's a bunch of agents here that we're going to use in other steps, and we can now interact with this. I'm actually using the Restate UI now to interact with this. This is basically, for any service, you can basically just go here, playground, then it allows you to. You don't have to go to the command line and curl all the time. Also, it's going to infer schema and so on for you. So prepared a question here, again, taken from Vercel's example, like a riddle. A taxi driver, has this hourly work and pays amount for gasoline, and so on. It uses fairly big numbers because when numbers get big, then the LLMs like to call calculators instead of like doing the inference themselves. So yeah, if we're sending this request, we should be able to see this in the invocation running. It's going to make a couple of, like a one inference call here, then a couple of calculations, and then goes to another inference call. So far so good. One of the I mentioned one of the interesting bits of durable execution is it helps you actually when agents are running for a while, and then when something goes wrong, that they don't really have to redo everything that they did before. So let's try and see what that means. We're going to maybe first use a very simple problem, namely let's actually just pretend we have a bit of a flaky network. So let's going to block just access to OpenAI here. This is just reconfiguring IP tables, so I can't reach it from my local machine. So if we're calling this here, again, we're going to see that this one tells us actually, okay, this isn't quite working. I cannot connect to the API. Unfortunately, the SDK doesn't give us a super good error message, but we can actually see it. It keeps trying, keeps working on this. It's going to go into more and more backoffs. Actually, I configured the backoff interval a little lower, that we get a bit more interactivity, but usually it would actually get to ever increasing backoff for retries, ultimately even suspend. What that means, we're going to see later. But it would not give up on the execution. And as soon as we actually make access possible here again, we should see the IP tables and the connection and so on have to refresh in the background, but we should see that this just like, at some point keeps going. So this one failed for a while, but eventually succeeded, and then the whole thing succeeded. Maybe so far that's not terribly complicated, because you could just have like a couple of retries around your model inference call and so on, and that should handle the situation. So let's make it even a little more challenging. Let's say we're gonna pretend it's an environment where really our processes and everything just could crash and go away. So I have another shell here which tries to do exactly that. If I run something here, it's just gonna inject a crash once in a while. So yeah, let's run this process again. Let's run it, like start our agent endpoint in there, and send a similar request again. You should see this is executing, and at some point in time, this is going to tell us, okay, I actually can't even reach the service anymore. Something must have happened there. Exactly that happened. The whole thing crashed. But you can see it actually keeps working. The next retry is in a couple of seconds always, and it also tells us, okay, the problem is I can't reach the remote endpoint where the agent code is actually running. That's what Restate server tells us. It's managing the durable request, the durable execution for us, and it tells us the code that runs the agent itself isn't actually running anymore. Let's bring it back up, and we should see basically that this whole thing that is like in retry just basically continued as soon as it could reach the endpoint again, and led to a result, right? So we didn't actually do any re-execution of previous steps. It just kept trying to continue from there, and we brought the code back up, and everything concluded. Again, there's like nothing specific we're doing in here other than really wrapping the tool call and wrapping the model call. There's no database infrastructure that we've brought here where we persist anything. There's no queues we've brought in. The only thing we've done is there's implicitly a queue through Restate, but we didn't really do anything else except putting the Restate broker in front of our deployment, and letting it accept the request, forward it to our service here, and manage the execution. The same mechanism allows us to actually do a bunch of really nice things also when it comes to human in the loop, long-running agents that suspend multi-agent interactions, even streams and persistent resumable sessions and all of this. Let's go into this in a moment. Let me pause here just for a second to take some questions. Okay, so
maybe one question. What was the motivation for having to manually put the restate.run inside of the tool call functions instead of just, for example, like wrapping generate text? Was there like a design decision that motivated that?
Yeah, that's actually a good question. Let me go into this one here, right? Like, why aren't we actually wrapping just generate text versus why are we wrapping this one here and this one there? You can wrap actually generate text. The thing is, though, generate text itself can be a fairly heavyweight, long-running operation, right? Like it can actually, the max steps here is actually the number of loops it does. It can do 10 times a model inference call. It can invoke, any number of tools in parallel multiple times. So the level on which you basically wrap is the granularity at which you'd say, okay, Restate can interject here, track the progress, and recover, right? If you wrap just generate text as a whole, it's kind of an atomic failure unit, right? And it's going to recover that atomic failure unit. It makes total sense if, for example, you don't have max steps here, because you say, okay, I just want one LLM inference, and it may tell me to use a tool or whatever, and then I interact with that manually. And then I'm building more of a traditional workflow of a sequence of, generate text and then inspect the input, and I might call it generate text another time, and then I might actually, depending on the input, go a different branch in my code. But then it can make total sense to actually wrap generate text. In the case where generate text actually does multiple steps, I just felt it's actually nice to wrap maybe a little bit more on a fine granular basis, so that you get more fine granular recovery. But ultimately, really, it's up to you. It would have been completely viable too. Then we would have to redo a little more work in case of a failure. But if that's that's the failure unit you want to define, that's okay.
Yeah, that makes sense. Thank you.
Yeah. There's a question, how can Restate help managing memory long-term, short-term for the LLM to build the context? That's actually a nice question. Maybe we can get to this in one of the later examples. I don't have this in the main set, but we have examples for that somewhere in our repository, and if we have a little bit of time in the end, we can get to that too. Maybe the TLDR is you can actually use what we call virtual objects in Restate, which are basically stateful versions of services, where you make the execution in the context of an ID, which can be user ID or chat session ID and so on, and then you can attach state in that context. For example, LLM context or just like a chat session context and so on, and have that available to forward to the LLM. So it's basically a way to make to make handlers remember state across individual invocations. So yeah, it's possible if we use Restate's virtual objects, and if we have a few moments in the end, I'm happy to show what that looks like. Okay, let me continue then and go to one of the next steps. So this is basically just the very basics of saying, okay, we have a simple simple agent that just has LLM inference and tool calls, and we're letting it become durable and handle failures in recovery. I mean, just to make it a bit easier, actually now launch this again in the shell where we don't inject failures so frequently. So otherwise, we're going to be watching retries more than the code. One of the next things that's actually fairly nice in the durable execution system is you can let the system take external signals. So this here is the idea here is for this example is an agent that, for example, evaluates a loan request. And if you look at the system prompt, it's actually structured in a very simple way. If if you're trying to get a loan to develop AI technology, just like go ahead and approve. If it's below 1,000, approve. If it's above 1,000 and unclear, use the risk analysis tool. The risk analysis tool, what it really is it sends an email to a human reviewer, and then it awaits the human reviewer's decision. And the way we can actually model this very easily is by saying, we're waiting for a promise, a persistent promise. That's how JavaScript, TypeScript calls it. In Java, you would say a future, or in Python. We're basically just saying, okay, hey, we're listening to the to completion of a future called approval, which is scoped to our agent here. I'm going to show you what that means in a second. So this is basically how that works, and we don't have to do much more. How do we set this up? We're doing something slightly different than before. We're not just defining this as a service here, which basically just has this one handler. What we're doing here is we're setting this up as what we call a workflow in Restate. A workflow is just a special type of service where that has a run function, which is like the main work, and then it has a bunch of additional handlers that you can define to interact with the execution. And in this case here, you can see there's like a handler called approval, and what the handler called approval does is it takes that promise approval and says, I'm going to resolve that promise, that future, with whatever you give me. Let's actually see what that looks like in action. All right, so yeah, there's when we invoke one of those workflows in Restate, what we have to give it is basically a workflow key or workflow ID. That is basically the scope and the ID under which we can interact with that workflow, right? So when we approve something, which one would we approve? That's basically identified by the key. So let's say we do loan 1. There's some SEM A's asking for a lot of money to develop AGI. If we send this, okay, we don't have that. Oh, I might have actually renamed that service. Okay, give me 1 second. That should be okay. Let's. I think I just renamed this a moment before the demo. Okay, so here we go. It's actually called Loan Evaluator now, not Human Approval. Okay, great. But so let's actually have SEM A do their thing. Okay, it's approved. If we go to the invocation, that was one of these rules where it actually completes it immediately. It doesn't actually have to go through human approval. Let me apply for a grant to not develop AGI, maybe to I don't know, go to Vegas. It doesn't have to be quite so much. I'm not that greedy. Okay, it's a different workflow this time. If we send that request, we should actually see this one going through exactly that path, right? We see it does the first model inference call, which says, okay, we need to run risk analysis. It notifies our human reviewer. The human reviewer notification is something as in our case, it's just basically printing something on the command line. And I think in reality, would actually let this send an email. And then now it waits for the promise called approval. And one of the interesting things you can see here now, it actually just suspended because it understood, okay, there's really nothing I can do at this point. I need to wait for this input. There's really no point to keep the agent alive, to keep the process up. Imagine you're deploying this on something like Cloudflare Workers or AWS Lambda, where you're built by the second or millisecond even. It's no point in keeping this process alive while it's waiting for the promise, right? So this is what Reset does. It basically just lets it go away and says, okay, I'm going to bring you up when the approval is there. Let's actually send the approval here for loan 2 or not. Let's actually approve it. Why not? We're sending this one, and we should see here. Okay, immediately this actually worked. We got the result from that promise, and that now we could feed this back into the next inference call, and we get an approval for our loan. So far, so good. So this basically lets us build these type of human in the loop workflows by using, in this case, we're using just a tool and a tool that, it's a long-running tool that suspends in the middle of its work because it depends on external data. This is one way to build human approval. Another way, I guess, to build it would be like multi-turn conversations, which I guess goes back to the other question in the chat earlier. How can you use it to remember context? That would be the other way, and maybe we can actually look at this towards the end. There's a bit of a special case here that you can also explicitly ask Restate to make a pause. This is an agent that we're going to use in one of the later steps. This is it's a very simple automated risk assessment agent. It doesn't really know how to assess any risks, so it basically just flips a coin. But it has a tool, pretend to think, which basically just pauses for 45 seconds in order to make it look like it did actually any work. This sleep, in this case, it might seem a bit a bit artificial and beside the point, but this is something you can actually use if you do want to do things periodically, or if you actually have like long backups. Let's say you have a research agent and it's supposed to like periodically try something. You can actually implement this with long sleeps. There's a counterpart to these long sleeps where you can actually basically schedule a tool or a call to yourself for the future. All of these things kind of come built into the durable execution. The interesting thing about that sleep is also it's not going to be like a sleep as if you just thread sleep. It's a durable sleep. It's going to make the process go away and come back after the sleep has elapsed. And if it fails in the middle, it's not going to sleep again 45 milliseconds, but it's going to look at the point in time when it recovers. Am I past the point where I should wake up again or not? Yes, if we actually interact with this one, it's just going to look somewhat similar to the other one. If we kick it off, let's actually see the suspension in action. I've currently configured the system into around about 15-second timeout before it goes to suspensions. So we should be able to see this exactly as the sleep keeps executing. At some point, we see the system's actually going to flip to suspension. It keeps waiting. We can actually, while it's suspended, even take the process away. It's going to not realize that the process has gone for the moment because it's anyways assuming that this has gone away. At some point in time, it will try to wake up and restore it. And then it's going to go into the regular recovery cycle. We can also just bring it up now and actually see that this means we're not really starting everything from scratch, but we're after 44.99 seconds, we woke up, we basically restored it and immediately completed. Let's actually show how we can use this also to to compose multiple agents together. Let's say we have our classic loan evaluator with a human approval. Let's assume this risk evaluator was actually a meaningful research agent that would actually go through your documents, through your credit history, and so on, and make an informed decision on whether it should approve a loan for you or not. This is what we've sort of done in this example here. It's a more elaborate version of Evaluate Loan, which has two tools available. The first one is the risk assessment. The second one is a human evaluator. And the prompt actually gives it a few rules. There's certain type of technology which it always approves, and anything below 1,000 approve, anything between 1,000 and 100,000 called the automated risk assessment agent. And if that returns low, you can approve. If it returns high, you need the human evaluator, and above 100,000, you always need the human evaluator. So it's a bit of I don't know, if an actual credit company would structure it like that, they'd probably hardwire the rules more than trust on the agent being precise in interpreting that. But it's just for the sake of this example, assume we're actually defining our our logic of how we want these to be handled through this prompt. And the tools that we structured, you probably recognize this one from the previous example, the human evaluator. It's again, we're sending the email, we're waiting the promise. The interesting thing is asking another agent to do work, in our case, actually looks quite similar. We're also using the tool thing here just because tool is the main sort of point that we can plug in this SDK. In other SDKs, you can probably use something like a handover or so. In this here, we're going to use tools as the sort of most general purpose way to extend or to implement other functions. So what we're doing here basically is when we see the loan request and we want to ask another agent to take a look at this. This is basically an RPC call to the other service behind which we host this one. Remember, everything in Restate is basically hosted as a service. Again, this agent here, we exposed this similar as before. This is our workflow service with a run function that calls this one, and then some auxiliary functions that let us interact with these durable promises. The risk assessment agent itself was also deployed as just a service here. If we go to the bottom, we're going to see here this is exactly how we deployed it. Pretty much like the like the initial example. Assess risk is our service, is our function within this service of this name. We're just going to call this function, and here we basically just define a bit of schema. And when agents are basically callable services, we can also call them just from this service here. So that's what we're actually doing here. We're basically creating a client towards that agent, and then we're asking it to assess the risk for us. So the interesting thing is if we're making an RPC call here, it works a little different than like classic, let's say classic RPC calls in other applications. It's really a back and forth queuing system, if you wish. So while we're making the invocation, we're actually putting an event for this service to be invoked, for this agent to be invoked. And we have basically a durable future on the response of that service here, which allows us also, again, to suspend while the other agent is working. And when this one is done, it's actually going to complete that future with its response, and then we can continue and wake up. So this actually looks like a sequential RPC interaction, but what it really is, it's like asynchronous messaging through queues. And because it's integrated on both sides with the durable execution mechanism here on the sender side, it's part of a reset operation. We're executing this through the reset context. And on the other side, it's a restate handler. We get this nice sort of end-to-end idempotency out of this without doing anything. Let's actually see what this looks if we invoke it. Should have an example here. So let's actually run here. This is our multi-agent loan evaluator. We're calling run on this. John is going to request $50,000 for a big vacation. That might be something that that falls exactly within the range that it goes to our automated research agent, and that's that one. Take a look. So let's send this request over and look at the invocations here. What can we see here? And we can see that our risk evaluator here got exactly that result from the first invocation. Okay, I need to call the risk, hand this over to the risk assessment agent first. So what we're going to see here is we're going to make a call to risk evaluator assess risk, for our parameters. And this is actually currently suspended our agent again. So this invocation is actually gone away. There's now no resource waiting because the risk assessment agent is taking its sweet time, and while it's working, there's really no point for us to stay here. Can actually go into that invocation as well. And this is the one that was just suspending. It should actually wake up and be complete now. Okay, so if we go back to our original invocation, to our multi-agent loan evaluator, we should see that this one has actually come back, and it came back with high risk. Okay, so what it did now is fall back to the next thing, human evaluator, and it's waiting on the promise. So so this is basically a way that we can let a process hand over work to another process. So this agent, while it's working, can actually say, I'm going to hand work over to another one. While that one's doing work, I'm actually going to go away, release my resources, and it's automatically going to come back when the other one is done. And because these RPCs and the whole messaging mechanism goes through Restate, it's also able to basically tell us exactly, like, it's got sort of an end-to-end timeline of what happens. So we can actually expand this here and say, okay, while this was executing, what was actually happening in the intermediate steps, right? Like, this is the sort of condensed view from just the loan evaluator, and we can get the details into what was happening in the intermediate steps. So it's kind of it's kind of a workflows end to end, even though we're sort of actually calling across different services. And yeah, can do the same thing here that we did in the previous example. Maybe this time. Maybe this time we actually deny it and see where this leads us. Yeah. Okay. Not the workflow ended. Denied. Okay. Let me stop here for just a second and see if there's any questions about this. No questions. Either I did an amazing job explaining this, or everybody's zoned out. I'm going to assume it's the first one. All right. Where is the code running was just something somebody asked in the code. So in this example, I'm actually just running this as a local process. This is what I've started here. It's just it's a local process, because in Restate everything is basically just it's just durable functions that are served. They can be served as serverless functions, or they can be served as long-running processes. In this case here, I'm basically just defining a Restate endpoint and starting this locally. It's like, think of it as if I starting a Spring Boot or Express.js or whatever application locally. I could take the exact same code, put it in a container, and deploy it somewhere in Fargate, or I could use a different endpoint, and then actually serve this on something like AWS Lambda or so. But generally, yeah, because it's all just like handlers that you serve behind an endpoint. It works exactly the same way if you run it on your local machine versus on some other service. I'm running it locally here, so I can just like kill it and restart it and redeploy it for the sake of the demo. So Restate doesn't manage containers. You deploy and leverage as a durable execution engine. That's exactly right. It's basically meant to be a durable execution engine that works with code that runs where you usually run your code. Trying to be as unopinionated as possible, and ultimately everything underneath the hood is HTTP requests with a bit of special support for some targets like AWS Lambda or so that don't accept HTTP requests directly, unless you put API gateways in front of them. Yeah. Any plans of having any agent-specific SDK in parallel to the Restate SDK? So, I mean, this is a fair question. At the moment, we're trying to basically go the route of saying, okay, we're trying to keep Restate orthogonal to popular agent SDKs, because I feel there's lots of SDKs around there. Many of them are developed by folks that are closer to, let's say, the models, or they're close to how folks structure the applications that use these SDKs, and they're doing a good job in developing the shape of these SDKs, the way you abstract agents and tools and handovers and guardrails and so on. And if we develop the 150th SDK, there's probably not quite as much value to that compared to us building basically middleware that allows you to run code written with other SDKs on Restate. So that's what we're trying to do primarily. So Restate specific, the stuff that we've written is basically this here. If you look at it's basically the following. We're importing, where is that? Okay. Actually, yeah. So we have a few packages like, for example, here, Vercel AI middleware. So this is a very small package that basically has a few utility helpers like the storable calls here. It has a few more ones in order to, for example, deal with offloading model inference to remote processes, doing a bit of like more sophisticated error handling and so on. But it's generally like very, very lightweight middleware that you then just use, with these SDKs, and it allows you to run the code with existing SDKs on Restate. In theory, you can, of course, work with Restate without any of these other SDKs. There's a few examples we do actually have in some of our repositories, like the AI examples repository here has, if you wish, under advanced. So Restate native agent, actually a couple of agents that don't really use an agent SDK. They basically just use like the tools for responses API, and but they don't actually assume any form of structured agent SDK that defines loops and tools and this and that. And for some cases, this actually works perfectly well too. So yeah, that's a long way of saying at the moment we're not planning to build dedicated Restate-specific agent SDKs, but rather build the middleware to integrate, to let other agent SDKs perform their work on Restate. All right. I can give you a quick look at one more piece, which is how can you actually use Restate to build sort of these end-to-end durable and resumable chat sessions. So one of the, and that goes a little bit into the answer also of context management. So let me quickly share the screen again and bring up another example here. Okay, so one of the things we really like, or I really like personally about Restate, is the fact that you can very easily use it to actually build a bunch of really cool tools that allow you to basically build custom queuing, custom concurrency control, or things like persistent sessions. What does that mean exactly? Let me show you this in a moment. So here, this is a Next.js app that is actually hosting a bunch of services, somewhat similar to the services I've defined here, specifically similar to this like initial tools service that where we post a question and it was iterating and calling a computational library in order to answer that question. And we're going to use this now. One of the things is this is the observability that we have here is nice. Let's say from the research perspective, we want to understand, okay, what did actually happen while we're going through this tool, so we can look at this invocation. But from the perspective of somebody who interacts with this thing, maybe they want to see the reasoning progress. That the way if you interact with these modern reasoning models and they show you their intermediate steps. Yeah, something like this. So you're not waiting for minutes and minutes and minutes. And you don't even have an idea what's going on. So this is exactly what we're doing in this next example. So what I've just started here is a mini web application with a chat interface and a couple of a variant of this sort of tool agent that publishes its intermediate progress. Let's take a look at what this looks like. I need to deploy this slightly differently now because it is a Next.js app. So it follows a bit of a specific structure and a specific protocol. There's lots and lots of, I actually hope this is going to work, and I'm not going to, you know what, let me be on the safe side and actually start a clean server here in order to demo this. Because I think this is going to, this has some name collisions, and otherwise there's I don't know, I didn't actually implement this in a super elaborate way. And before I actually get into, you know, some of the services I deploy here, shadow some of the others, and then I'm lost in the you know, I'm figuring out which one is actually the one I deployed. Let me just you know, start from a clean slate here. Okay, so this is a bunch of services defined in this Next.js app. If we go to this side now, we can do something like this. We can actually pose it these type of questions like this, you know, this math riddle here. And while it's running, it's actually going to tell us it's actually going to show us the initial intermediate steps to which it goes. Okay, what do I need to find out? What tools do I need to call? What are the results of the tool call? And what is the remainder of this? And so the interesting thing is this is basically a persistent stream back from our agent running to the browser. It's not actually just a persistent stream. It's actually even it's a shared session, right? Like if I put the same URL here, I'm going to get the same session here, right? So it's like almost it's a persistent session. I can ask this question again, and we're going to see that you know, it basically synchronously runs in both of these windows. So we've basically a PubSub here where the agent publishes messages, and our interface actually subscribes to these messages. This is actually an extremely simple thing to build in Restate as well. These few lines here, this is basically the like 108 lines, and that includes schema definitions and everything and imports, right? Is basically a persistent PubSub that, you know, that the agent can publish to, that different clients can subscribe and resubscribe. And you know, even if we start if we copy this to another window, we're going to see the complete previous history here. So, you know, and they're going to now receive updates as well. So this sort of like persistent, subscribable, resubscribable channel is with everything, with schema and import. It's like 108 lines in Restate. And then all we actually need to do in our main agent is something like this. We need to actually tell it to, we need to, you know, call publish message to that service that implements this persistent channel. So we're publishing the initial prompt, and then we have a hook here. When the step is finished, we're going to publish a message. You know, what was the text? What was the tools that were supposed to be called, and what were the results of these tool calls? And that's really it. The PubSub itself here is a Restate virtual object. So it's one of these like services that maintain state, and it's basically a virtually sort of infinitely scalable PubSub, in the sense of like every session has its own ID, basically gets its own queue object to which it can publish and subscribe, and you can pretty much have as many of those as you want. They're completely isolated against each other, and yeah, that's it. Let me pause here again and take a few questions if you want. All right, I think this is yeah, there is a few questions here in the chat. Let me actually go through this. There's from Martin: it would be cool if virtual object state was automatically pub-subbable. I think this is a really nice thought, and it's something that we've been playing with for a very long time. Basically, have sort of like change data capture-ish functionality for virtual object state. Yeah, I think this makes total sense. That would even make this implementation simpler, right? Then I think it would basically just like append this to that to that channel's state, and that's it. And at the moment, there's a few lines that actually access the state, register a persistent, like an awakeable, a durable callback in order to notify, to signal, okay, here's somebody that wants to be notified if there's anything else. Because you don't need to build retries and failure handling and concurrency and so on. This is generally not too much code, but I get it. We could probably get this down to 20 lines if the state is sort of like automatically subscribable to. There's another question. Does Restate follow actor model principles internally? That's actually very good. A very good question, because the answer is yes. Virtual objects, you can think of them actually, they're stateful actors mixed with durable execution. What we basically get. Okay, I closed no, we're still here. So yeah, basically each of those ones here now defines an individual actor, an actor that manages that session that you can push data to and subscribe from. The actor itself is stateful. So if we go to the pub-sub here, we're going to see that this has, for example, when you publish here, you can actually get certain fields from that actor. Here we're just getting a field called messages. We're adding to the existing array our latest message and then updating this field again. We're also managing subscriptions here, and each of these methods is basically a function on the actor that follows actor semantics. So they get an isolated view of the actor, and the future functions are enqueued, so they execute after the ongoing one is done. But each of those functions itself is like a durably executed function. So like it gets workflow semantics during its execution. That I think this is where it becomes really powerful, because now you're actually getting the sort of the statefulness, the lightweight concurrency of the actor model with the sort of resilience and composability of the durable execution model, where you don't have to worry about anything failing in the middle, and does that leave your actor in sort of a partially incorrect state. Communication with that actor is guaranteed to be end-to-end reliable and idempotent exactly once. All those niceties that you get out of a durable execution system sort of basically integrate into the actor model. I think it looks like most of the other questions were already answered by my colleagues in the chat. There's a few more questions around like how do you version long-running workflows when it evolves. This is actually a fun topic in itself. I'd actually point you to the documentation. I think if we go into the details of this, I think we're gonna blow this meeting. But I can tell you as much as that there is dedicated support for that in Restate, with keeping different versions of workflows and durable functions, and and understanding on which version the workflow started, so you can actually pin an ongoing execution to an ongoing code version, so you're not getting the problems of like non-deterministic changes that break durable execution while moving new invocations to newer workflow versions. I pasted a link to the documentation in the chat that actually goes into a few more details. Thank you, Martin, for the kind words. Restate is very cool, probably my favorite implementation pattern for I've seen so far for agents. Thank you. It's mine too. All right. If you folks want to stick for just a moment, then I can quickly just show one last bit about like state management for sessions, as I mentioned earlier. And we can use the same examples here. So this is, let's say, this is a chat agent where we're using Restate to manage context and memory. So it's an extremely simple one, right? Like the only state it remembers is basically an array of core message, so everything you've asked it before, and it has one function which is message, and what it does is it actually, other than like doing the same setup as before, we're taking the we're wrapping the model to make it durable. What we're doing is we're actually going to get the messages from the state. We're taking the messages, we're concatenating the next user message to it, and then we're feeding this through our text generation, and then before returning this, we actually store the response in state again. So we're taking the current messages plus the new messages that come out of the response. And that is it. That way we can actually let the system remember things. So let's actually look quickly at how that what that feels like when we interact with it. So if you're interacting with a virtual object here, which is like the mechanism to have these sort of like stateful entities. It looks the following way. So we're interacting with Restate chat. Then you can see the key here, message. The key is basically the name of the object, of the actor of the session that you're interacting with. So for example, if putting my own name in here and hi, I'm Stephan, nice to meet you. And okay, what? And then very nice. And then I ask it, what is my name? It should actually know that because we're letting it remember it. Don't seem to be getting an answer now. Okay, very good. Let's actually use this to debug this. Use the Restate UI to debug this. Okay, let's actually see. Service is chat. This one is still running. Why is this one still running? We're calling the model, and the model is not responding, but it's also not throwing an error at this point. It just seems stuck. Let's actually see if we can get can get something out of this one. Okay, I might have actually killed messed up the root while I was preparing for this demo. Okay, so sorry, this happens. That happens during live coding. I removed a lot of these roots here, unfortunately. Might have to rebuild the application in order to make it work. It's in a bit of a weird state because it's I think it's relying partially on a compiled cache and partially not. So apologies for that. Generally, if you interact with a system, you would this is if you interact with virtual objects, you always have to basically provide the name of the object that you interact with, and then this actually remembers the history. If you give me a few seconds, I can rebuild this, and we should be able to get this running in a moment. Yeah, let's actually take a look at a few questions. Okay, what are the next few themes you're looking at for additional AI LLM agent support? How is that question meant? Like, what are the next patterns we're trying to add support for? Yeah, okay. So there's a lot of directions. There's a lot of directions to go. I think the first one is that we do definitely want to wrap up a lot more of the utilities that we have, for example, in these in these examples here, like like the PubSub, the way to manage a chat session and so on. Just like put this into this like middleware library, so you can basically just say like, okay, let me import a chat session and then like or a PubSub, and then you basically get this sort of queues. Because I feel a lot of the work when you build these these applications in a bit more serious way goes actually into the plumbing. Like, how do you actually manage the interaction between the agent and the human? Let's say the more sophisticated version of this loan workflow, maybe we can actually do a follow-up meetup where we can go through this, where you would actually we actually put it's more of a claim processing agent, actually, where you put a claim there, and then you have an agentic substep that says, okay, I'm going to research all the information around this claim, and I'm going to ask the user to provide this and that data if it feels like this is an incomplete picture, and so on. Like all this like back and forth between the agent and the user, right? Like it looks super simple in most of the examples. Just make it a multi-turn conversation or whatever, or just send it and like wait for a message here. But like if you actually plumb this together, it's where you can easily spend 80% of your time on this. But this is actually one of the strengths of a system like Restate, right? It makes actually this sort of like connectivity pieces, these plumbing pieces, are very nice. So this is definitely one of the areas where I think we should publish a few more utilities and so on. The other bit is going more in the direction of these examples were simple in the sense of they basically just kicked off one agentic loop, and then they had a suspendable tool or a tool that called into another agent. But a lot of the, I'd say, more real world examples, they're not, okay, here's an agentic loop with a super big prompt and a set of tools, and now go do your work, right? Like I think the really successful, sophisticated agents, they're like to a good extent imperative flow, where you maybe make a few control flow decisions based on classifying input through an LLM and so on. Then you may have like a micro agent that is like a step in that workflow. And these things actually work really nice with the durable execution system as well, because it's not like heavily tailored to just agents. It's actually something that generalizes beyond them. So it's really good at sort of mixing the more traditional workflow logic, like with agentic logic, right? So you don't have a workflow for your traditional logic and then an agent, and then like this calls into this. It's actually just like one single workflow in the end. It's just some of the steps are imperative defined. Some of these steps sort of like the agent comes up with them as it loops. And that actually, I think, is the real power of a system like this. It's a bit more. It's not the hello world agent use case. This is, I think, when you try to when you start to make it real, start to integrate them with your existing workflows. When you build the sort of like connectivity with the other systems, with back and forth with the user. I think this is where it becomes even more powerful. And I think that's a direction I would like to strengthen in the future. But definitely happy to. I mean, these community meetings are partially for us to hear, what would you actually like to see? Like where do you feel like this could really use better support?
Yeah, that actually resonates, because one of the things I was looking at earlier was like trying to wrap my head around sort of like the mental model for Restate, and like one of the things that I was trying to process was like is an agent a workflow or a virtual object or a service, or some, like in Restate terms, or some combination sort of all of those things. And maybe plus one to another question or comment earlier in terms of like how that all relates to like the context management, and perhaps even being able to have more visibility of the constructed context in the Restate UI as well.
You can actually have that. Let me try and get this other example up and running. I'm sorry that this is a bit of that was not one of the prepared parts for the demo. So I'm to reconstruct a bit of in the middle sort of dev ongoing code snapshot. Let me see if it works this time. Just recompiled everything. So yeah. Hope this actually this is actually going to work now. So if we go to the chat session again here, and yeah, so let's say my chat session is whatever, session 1. So, okay, we're going to get this this response here back. So you can, yeah. So we have this all sorts of invocations. Okay, we're still pulling from this channel and we're not finding this. Okay, this is why all these failed invocations are there. Ignore them for the time being. If you go to state, you can actually see exactly that. If we go, for example, to chat and query this, we can actually now see session 1. If we go there, this is basically all of our state. Or here we can actually see it even nicer, right? Like this is basically everything we stored in there. And if we do in session 2, somebody says, I am, I don't know, Jane, then we're going to see, okay, we actually have these 2 sessions going on now, right? Let me now ask Jane, hey, do you know who I am? In session 2. I don't have access to a personal individual. Since you mentioned your name is Jane. Okay, that's all I know of you so far. Fair enough, that's a good answer. So yeah, in this session, we have done exactly that context. So yeah, it actually knows that this is it. And if if we ask somebody in a completely different session, do you know who I am? There, we shouldn't actually have anything. No, don't know anything, and we should see session 3 has actually popped up here now. So you can get a bit of that. Can get some of these insights. I guess what is actually something that could be fun for one of the next things is trying to group these things a bit together. If you're building sort of an agent template, then to say you have the invocations connect like from a specific agents together with that agent state sort of in a view side by side. You do have all this data right now. It's just on different pages. There's invocations versus state. I want to say though that like the experience should be pretty customizable because Restate's backend is just SQL actually. So you can always sort of build your own view by just issuing these queries, right? We can actually see there's a bunch of chat state for session 3, session 1 messages. There's the values in binary and UTF-8. There's also the PubSub, which currently holds only a subscription because we had the other page open that was still pulling, even though nobody was publishing there. And it goes actually beyond that, right? Like we can we can also do check this invocation for the execution progress, right? And we can see, okay, from all the virtual objects, because the only things we had were actually PubSub and chat, which are all objects. Those were the invocations, those were the journals and so on. So you can kind of access that, and if you want, customize, I guess, the UI with a little bit of, can probably vibe code a different UI that actually puts this side by side. Maybe that would be actually a cool project for us to do at some point in time. Just use that and
Yeah, that would be very cool because that would kind of like obviate the need for one, like the general like open telemetry style tracing and spanning, but also like the LLM specific observability tools as well.
Mm-hmm. Okay, perfect. We're actually way over time. I'm not sure if you folks want to hang around a bit more, but yeah. I'd say from my side, happy to wrap this up for today. I feel like we should do another one really soon because there's so much follow-up. Like we can go a little more into how do you actually build an agent that uses sort of a separate session to interview a user and collect more data. How do you, different patterns for like human in the loop, use a virtual object to maintain state in a multi-turn conversation versus, make this a durable future. Pros and cons for both approaches. There's so much we can do. The interesting thing is we've tried to build the foundation of Restate as these like very orthogonal and general building blocks: durable execution, virtual objects as stateful actors, workflows, durable futures, and promises. You can kind of compose things in the way that feel most natural to you. You don't have to follow an exact pattern. If you want to say, okay, I'd rather have the agent feel like a long-running workflow and send a signal in there as a human, approval, then this is the pattern we used here. If you feel like you want to do a multi-turn conversation, just make it a stateful object. Remember the chat history and push new messages and concatenate them there. You don't need to do much around it. It's kind of up to you. Yeah, I feel as this agent space is evolving so much that we want to probably preserve this for a while, and maybe at some point in time when certain patterns sort of evolve as, okay, this is the textbook way you're supposed to do this, then maybe we're going to go and create a few more opinionated patterns for this. But at the moment, I feel it's kind of helpful to say, okay, wherever these SDKs take you or wherever the design patterns take you, should be able to just map this to the runtime rather than being forced into a specific structure. Because that's one of the biggest, I think, criticisms I've heard of most of these AI SDKs is if you go to something really sophisticated, often people kind of start to walk away from these SDKs because they start to narrow you in how you design your software and your application. And at this point, we don't feel we want to do the same thing with Restate. Yeah, maybe that's a good final sentiment for this community call. All right, thanks everyone for joining and for staying over time. See you around for the next one.